I'm back, and now we want to do part 2 on adding waves together. So now you should have an understanding for what frequency and amplitude and wavelength are for a wave. But now we're going to take two waves and add them together, and we want to see what happens. So you're going to open this simulation, so just click on this thing right here. Okay, now you're going to go to this and then position it like that so that you can kind of play around with it. Now notice that we've got two waves. So we got a green wave here and we got a blue wave here. So these sliders are going to control the blue wave, and then these sliders are going to control the green wave. And you'll notice that there are three things that you can change about the wave. Okay, so I want you to play with the sliders here. So this top one, if I move it back and forth, let's see what happens. There it goes. Okay, so I took the blue one and I moved it off to the side, and do you see that this blue one got taller? Now you should know, what does that mean? So what did we call that? So the height of a wave was the blank of the wave. So that's what this top one does. And then you can also grab the green one and you can also change it. Okay, now let's skip on down here to the bottom one. So the bottom one is going to be the frequency, but you'll notice that they use a different letter for it. I use this one here for frequency, and technically that's called the linear frequency of the wave. But you notice that on the simulation there, they use this one, which is called omega, and it is going to be the rotational frequency of the wave. It's not important. So it's the frequency of the wave. So that's all that matters. So in your head, if you want to think of it as being this, or for that matter, this for frequency, that's perfectly okay. So I want you to grab this one and then again move it back and forth and then see what changes about the wave. Now you might be saying to yourself, oh, that's not changing the frequency, that's changing the, what was the distance between here and over here? Okay, that was called the wavelength. So you might be thinking, well, that changes the wavelength, not the frequency. Au contraire, because we just learned in the previous part that the speed v of a wave is going to be equal to the wavelength times the frequency. And so by changing the frequency, you're also changing the wavelength. And I did want you to notice that if you increase the frequency, look at what happens to the wavelength, and then just make sure that this formula here is working. So this v would be the speed of the wave. Now, you'll notice that they're not moving. Now, I believe that we can actually change something on the simulation to make those waves begin to move, but we're not going to do that. So this is actually much nicer that the waves are not moving, but technically they are moving with a certain speed, and then that would be this thing here, and then they have a certain frequency and a certain wavelength. So that brings us to this blue slider up here. And I want you to move it back and forth, and I want you to observe what happens on the screen. And this is going to be called the phase of the wave. So I wanted to explain to you, what do we mean by the word phase? Okay, so if you go around in a circle, how many degrees is that? Okay, I heard somebody say it. So that's going to be 360 degrees. Okay, now there's another way of measuring the angle through which it goes, and it's going to be called radians. And so radians is going to be in terms of pi. And so if this thing goes around in a complete circle, then that is going to be called 2 pi radians. And so that's another way of thinking about it. Okay, now let's take a look at this thing here. So my screen is getting too cluttered. So let me get rid of some of this so that I can make a better picture. And so I'm going to make a graph here. So this is going to be t for time down here. So time is going by as you're going in this direction. And so let's pretend that our wave is going to start right here. Okay, and so it's going to start at 0 time, and then it's going to go up, and then it's going to go back down, and then it's going to go back up again. And then notice it repeats itself. Just like the circle repeats itself when you go around one complete circle. So instead of the letter T for time, we could also, so let me just get rid of this. Okay, there we go. We could do it in terms of an angle. And we could say that this over here where it begins is 0 degrees. And then over here is going to be 360 degrees. So it starts over after 360 degrees, just like the circle over here did. So what would that make this point right here? So if this is 0 and this is 360, then this would be 180 degrees. So that would be right there. And then we could even figure out, what would this one be, and then what would this one be. So I'll let you do that. But this is going to be the, when we say that we're going to change the phase of the wave, what we're doing is we're changing where does it start at. And so you'll see up here that it's giving you a number for where it's starting at. Okay, so I'm going to take this thing here and I'm going to adjust it. So do you see the blue one is starting right here at the origin? And then do you see that this is saying about 0 degrees? So that's its phase angle, 0 degrees. But it doesn't have to be that way. So if I took this thing and I moved the phase, the slider thing, I could start it so that it's right up here. And so you see that that's going to change this angle up here. So I could take whatever this thing is. So if this is 180 and then this is 0, then halfway in between is going to be 90 degrees. And so I can take this thing and I can slide it over. So again, how about if I put it up here? So I could start it, my wave up here, and then it's going to go down, and then, I kind of like what this thing, so just have a cup of coffee while I'm doing this. I'm a professional, so how about if I do this? So let's take this thing and then move it up to here, and then let's take this thing and then move it up to there, okay? And then I'll take this thing, and how's the weather where you're at right now? Okay, and then we're gonna take this thing and put it up there. All right, so now I'm gonna start up here. Okay, so that's this point right here. And then I need to go down, so then it's gonna intercept right there. Okay, then it's gonna be underneath when it gets to here, and then it's got to intercept when it goes up to here, and then it's got to be up at the top when it's up here. Okay, so what I've done is I've taken this thing here and I have slid it backwards so that this point is that point up there. Well, the net effect is that I have changed the phase by 90 degrees. So by going from this picture here to this picture, I have slid it 90 degrees. So that's what we're doing when we're changing the phase angle. Who cares? Now we're at the point where we're going to add the waves together. And so if we go back to the lab here, okay, now we're going to go down to here. Okay, you're going to change the amplitude, change the phase, change the frequency. Okay, move the phase angle. What is happening to the wave? Well, we've pretty much shown what that's going to be. Now it says to click the box that says show hide y1 plus y2. So one of the waves is y1 and then the other one is y2. And so if we click on this box, okay, now we get the sum of the two waves. Now, the way that we do this is, do you see that we've got a grid pattern on there? And so this one has a height of 1. This box has a height of 1. So look at the blue one. Okay, so let's say that we're along this line right here. Do you see it goes up to like 1.25? Okay, now let's take a look at this one here. Do you see it's not quite as tall? So this one is like at, oh, I don't know, 0.75. So if you were to take 0.75 plus 1.25, well, you're going to get something just a little bit bigger than 2. And then, do you see up here? So the height of this red one up here is a little bit more than 2. So it took this height here and it added it to that height, and you get this. Well, what about right here? Well, do you notice that the blue one is above, so it's a positive number, but oh, that's the green one. So the green one's above, and the blue one is underneath, so it's a negative number, and when you add the two numbers together, they're canceling. So do you see that the red one is going through 0 at that point? So this thing is adding these two waves together. Now, your goal is to figure out when does constructive and destructive interference occur. So I'm not going to tell you. So if you don't know, go to the internet and find out what is constructive and destructive interference. What does it look like when two waves are interfering constructively? What does the wave look like? And then when they're interfering destructively, what do they look like? And then under what conditions? So the frequencies of the two waves have to be related to each other. So look it up on the internet if you don't know. But I think that after you play around with the sliders, you'll be able to figure out what the two frequencies have to be. And then the amplitudes also are going to be related to each other. There's a specific amplitude and a specific frequency relationship between the two waves. And so if you dial that in for the frequency and then the amplitude, and then once you got that figured out, then change the phase angle. So that's the third thing that you got to do. First, figure out how do we need to fix the frequencies and the amplitudes of the two waves. Then, how do I need to move the phase angle? And then you'll be able to notice constructive and destructive interference. So actually, let me just do this here. I'm going to move this back and forth. So do you see how the wave is changing depending on the phase angle? Well, if you get the frequency and the amplitude just right, something very interesting is going to happen to the wave. So that's all this part of the lab, and I will let you do that. So when two waves are constructively interfering, fill in the blanks. And then constructive interference of a sound wave, so these could represent water waves. What about if it was a sound wave? So the sound would be extra what if it was constructive interference. Now we're going to set the phase of the green wave to 180 degrees, and then something different is going to happen. So you're going to fill in these blanks here. And then destructive interference for a sound wave would make the sound extra what? So now you should have an understanding for what constructive and destructive interference are, and then we're going to use that when we do double slit interference in just a moment. So I will see you then.